Many sequence problems deal with r to the nth power, and we have a theorem that says r to the nth is convergent if r is between -1 and +1. Notice that's -1 exclusive and +1 inclusive, and it's divergent for all other values of r. And if you look at that limit, if the value for r is between -1 and +1 exclusive, the limit goes to 0. If r is exactly equal to 1, then the limit is 1. Well, so what are we looking at? So what do I mean? That is, here we have what is the limit as n approaches infinity of 1. Well, it is 1. Well, I guess that's 1 to the n. Again, it's just 1. So what about at -1? What's happening there? If we have the limit as n approaches infinity of -1 to the n, we saw that one. That was the case where it was alternating between +1 and -1. What about the in-between case? The in-between case is if you raise a fraction between -1 and +1 to a large power, that fraction is going to get smaller and smaller and smaller until you get to 0. Well, until you get close enough to 0. A sequence is called increasing if the next value of the sequence is larger than the previous value of the sequence. It's called decreasing if the next value of the sequence is smaller than the previous value of the sequence. And it is called monotonic if it's either increasing or decreasing. So the question is, how do we see that the sequence 3 over n plus 5 is decreasing? So if we think about the next value of the sequence, how does that compare to the previous value of the sequence? Which of these is bigger? Well, 3 over n plus 6 compared to 3 over n plus 5. If you divide by a larger fraction, your quantity becomes smaller. So this is a decreasing sequence, since, I guess if we're going to write it in the way they write it, a sub n is larger than a sub n plus 1. So how do we show that this next one is decreasing? Well, what we want to see, want to see that a sub n is larger than a sub n plus 1. Now, hopefully we're going to come to something that shows that this is true. That is, if we have n over n squared plus 1, we want to see that that is greater than n plus 1 over n plus 1 squared plus 1. So what are we going to do with this? Well, notice that the n's are all positive numbers, so it would be okay to clear the fractions by multiplying both sides by common denominators or cross cancel or whatever you want to call it. If we were to clear clear out the fractions, you're multiplying the left-hand side here and the right-hand side over here. And why is it important that the n's are positive numbers? Because if we were to multiply by a negative, that would change this inequality sign. So is this true? How do we know if this is true or not? It's not obvious from this point yet. So let's FOIL this out. Let's distribute some stuff. Go up to here. Squaring this is going to be n times n squared plus 2n plus 1 is 2 is greater than, and distributing this gives me an n cubed plus an n squared plus an n plus a 1. Okay, distributing the left-hand side, n cubed plus 2n squared plus 2n is greater than n cubed plus n squared plus n plus 1. Okay. If I subtract an n cubed from both sides, those cancel out. Let's bring the n's to the left-hand side. Bring the n's over to the left-hand side gives me, subtracting n squared gives me 1n squared. Subtracting an n gives me n. And the number on the right is just 1. So the question is this true? What kind of values are n? N is 1, 2, 3, and so on. So the smallest that this can take would be 1 squared plus 1 is 2. So that is true, no matter the value for n. So a sub n is larger than a sub n plus 1. So the sequence is a decreasing sequence. Next we have a definition. A sequence is bounded above if there is a number m such that all of the a sub n's are smaller than or equal to m. It's bounded below if there's a number little m such that all of the a sub n's are larger than little m. And we call it a bounded sequence if it's bounded above and below. So you can imagine here's a big M, here's a little m. Our sequence stays between big M and little m. Now, just because it's bounded doesn't mean it has to be convergent. It's just that we have an upper and a lower bounds for our sequence. Now, if we also add that it's monotonic, then it is convergent. So now, here we have a bounded, above, below. Monotonic means it has to be strictly increasing or strictly decreasing. So now if I pick a strictly increasing, okay, it's increasing, it's got to keep increasing, it's got to flatten out, it can never cross larger than m. So it would be convergent.